Hello everyone, this is video 3, test 3, the extra credit for chemistry, test 4. So I should already, question 1 and 2 should already be posted above this, but this is just question 3. Show that phenol is more acidic than cyrohexane. So this is phenol and this is cyrohexanol. So when it asks which one is more acidic, you should always think of acidity. When you think of acidity, you should always think of conjugate bases. So step 0, I guess, is to find the conjugate base / negative charge. So you can just do this by removing the hydrogen. So for this one, for methanol, I'm just gonna redraw it down here. So, and then you use an octane rule. There should be 2 lone pairs here, but organic chemistrists or organic scientists are lazy and they don't like drawing the lone pairs, and it's pretty assumed, so they just don't. And then you just have to, when you redraw it, you just have to redraw it with them. The reason why you know there's 2 lone pairs here is because of the octane rule. Oxygen needs 2 bonding, or 2 bonds and 2 lone pairs in order to fulfill the octane rule. So you know there's 2 lone pairs here because there's 2 bonds. So you just remove the hydrogen, and you get a negative charge too. It'll be the same thing over here. So this is where the negative charge and the conjugate base would be. So 1, compare the size. Compare size of, compare size, sorry for my bad handwriting, but compare size of the atom that the negative charge is attached to. In this case, it's oxygen versus oxygen, so it's the same. Step 2 is electronegativity. And the first one, atom itself. Oxygen versus oxygen will obviously have the same electronegativity. And then neighboring would be carbon. This is carbon, which is the same. So step 3 is resonance. And for resonance, in order for an atom to have resonance, it needs one pair, and then B needs a double bond. So which one of these has a lone pair of double bonds? It's phenol. So this is how you should visualize drawing resonance. So you label the atom with lone pairs. Or just imagine, I just rewrite this. So this would be, you label the atoms with lone pairs as 1. You label the middle atom as 2, and then you label the atoms the atoms with the double bonds 2, 3, and then visualize it like this. This lone pair becomes a double bond. This double bond, or this bond right here, becomes a lone pair in this atom. And then when you move the electrons like this, then you lose a negative charge on the oxygen. So let me redraw this. I'm really bad at drawing hexagons, so like, I apologize for like my horrible drawing skills. So it looks something like this. So you can see how the double bond that was previously here became a lone pair, and then the lone pair right here became a double bond. And then can you see, you can continue doing this. So we have 1 here, 2, 3, draw this out. This becomes lone pair. On this one. Let me just erase this so it's not confusing when I look back on it. Let me check if I'm doing it right. Yeah. So this should also be a double arrow because they're both residents of each other. So when you draw that out, there'll be double bond here because this lone pair turns into a double bond. And then this double bond turns into lone pair here, so that would be negative charge there. And then this bond would still be the same. You can go even further. 1, 2, 3. This would be transferred here to a double bond. This would be transferred here into a lone pair negative charge. So we draw that over here. This lone pair over here, the lone pair that was right here turns into this double bond, and then the double bond that was right here turns into the lone pairs. And then we can go even another step further. It would be 1, 2, 3. So start visualizing it. Let me just draw out here so I have more space. So you might think this is like this is the same atom as the original, this one and this one, but you can see that the double bonds are placed in different spots, making it a different, like making it not the same structure. So that means that since it's over 5, the negative charge would be negative charge on the oxygen would be kind of like split over 5 different atoms or the 5 different structures. So that means that phenyl can handle negative charges better, making it more acidic. So phenyl would be the right answer. Just do a quick recap. You first find the conjugate bases and negative charge. So you just remove the hydrogen, and then you compare size of the atom for the negative charge, and then you compare the electronegativity of the atom itself, negative charge, and then the neighbor atom, which in this case is both carbon, it's the same. And then you do resonance. In order for you to do resonance, you need a lone pair, and then you need a double bond, and then the lone pair becomes a double bond. The double bond becomes a lone pair, and that moves the negative charge. And then since it has more resonance, that means it means it can handle the negative charge better, making it more acidic. So thank you for, I guess I should circle this one. Thank you for watching this video, and test 4 should be below this one. Have a nice day. I can see you in question 4 if you are watching question 4.